Yes, hello everyone. This is Janda Chimuni Aloysius, and I'll be doing a presentation about explainable AI and deep transfer learning for maize disease diagnosis. And here are some of my group members. And the presentation will be by Janda Chimuni Aloysius. I'll begin off with the introduction, with the contents of the presentation. Introduction, problem statement, related work, research questions, objectives, methodology, experimental explanation results, conclusions, future research direction, influences, and acknowledgements. With the introduction, we shall be carrying out a study of the use of explainable AI and deep transfer learning for the diagnosis of maize streak and maize leaf blight diseases. The goal of this project is to empower farmers, improve agricultural productivity by enabling the accurate and efficient diagnosis of maize diseases. And below are some of the images of the plant diseases of the infected maize leaves. The problem statement, as you well know, maize is one of the major staple crops across the world, and many smallhold farmers, like it is maize is a source of income to many smallhold farmers across the world. And due to increased production of maize over the years, there has also been increase in plant diseases. This has called for development of systems for diagnosis of these early detection of these maize diseases. Traditionally, professionals, agriculture professionals, though, with the knowledge and experience have been used, like have been employed to diagnose these diseases, may using either eyes, visual inspection, laboratory inspection, and culturing, which has seemed to be ineffective in such a way that the results are not accurate. As you know, human is to error, not accurate, require use of modern equipment, which is kind of expensive, and also like consumes a lot of time. Several technologies have come up to deal with the issue, like modern, like deep learning has been employed, but then it has been able to diagnose the diseases well and good, but then there has been some limitations of not providing the explanations on how the models have come up with the decisions they have made, the predictions they have made, which has led to people not trusting the models. And also for those models, like the results have not that been accurate. And that brings us to our study today, for use of explainable AI and deep transfer learning to tackle that issue. To ensure sustainable maize production and enforce food security and prosperity, we must be able to diagnose maize disease in their early stages of infestation, and this can only be done by reliable and efficient methods such as deep learning techniques, that is to say, image classification. For our related works, like the people who have done research in the same field, we have Chen and Wang. They developed a maize disease detection system using the PNN, the probabilistic neural network, and image processing. The method involved the use of support vector machine and artificial neural networks for identification and categorization of maize leaf diseases. And then another one, we have Zhang. Zhang used improved versions of GoogleNet and Cypher 10 models based on deep learning for identifying maize leaf diseases, and he achieved, the GoogleNet model achieved an average identification accuracy of 98.9, and the Cypher 10 model achieved an average accuracy of 98.8. These are some of the research questions that will guide our research. How can we perform exploratory data analysis on the Maize dataset. How can we create and train an image classification model from scratch to detect maize streak and maize leaf blight diseases? What pre-trained image classification models will be chosen for the purpose of maize disease detection? How can we evaluate the three models' performance to select the best performing model for maize disease detection? What example AI techniques can we use to explain the selected model? What platforms can we deploy our machine learning model on for maize disease diagnosis? I will begin off with the objectives. The first is to perform exploratory data analysis on the maize disease. This is to just ensure data cleaning, then create and train an image classification model from scratch, as well as utilizing two pre-trained models, like where we shall get from the AI lab, that is the ResNet 50 and the VGG19. Then the second objective is to evaluate the best performance model among the three models using the precision recall, area under the curve, F measure, and then our third objective will be analyzing the best performing model, best performing black box model, and explain how it has been able to make predictions using explainable AI techniques, e.g. the Lime, Sharp, ARP. Then finally deploy the machine learning model on a mobile application using TensorFlow Lite and React Native, and also develop a web-based application using Django framework to serve as a dashboard for the data collected in the database. Then for our methodology, this is what we shall follow. First, we shall get our data, do some preparation and data analysis, that is to ensure that the data is clean. After that, we shall design a CNN, a convolutional neural network model. Then we shall be building one model from scratch, and the other two we shall also utilize some other two pre-trained models. Then we shall carry out some transfer learning just to ensure transfer of knowledge, so as to customize our own models. Then after that, we shall do the model evaluation to get the performances of the individual models. Then after that, we shall do the model explainability to provide the rationale behind the decision-making processes of those models. Then after that, we shall deploy our models on applications platforms for people to use. Then for dataset description, for our dataset, is composed of 15,821 image data, and also an Excel file for each class collected from the Uganda's key maize growing regions. For each instance in the Excel file has a crop image with an image set such as healthy, maize leaf blight, or maize streak virus, as well as crop variety, crop age, and location. Below here, we are basically explaining the methodology we shall use: exploratory data analysis and preprocessing. The maize images will be analyzed and preprocessed in order to prepare them for use in the AI-based diagnosis. That's basically to remove the irrelevant images and maybe focus on the most significant features that we shall use for creating the model, training the model. Then after, we shall augment the dataset to increase its size and diversity. This is to enable us, maybe for a model to better learn very well, we need to feed it with some large dataset. So this augmentation basically will increase the size of the dataset and diversity. We shall then normalize the data to ensure that images are in a constant format and range of values. Then splitting the dataset into training, validation, and testing. The training set will be used to train the model. Validation is to tune the model while it is being trained, and the test set is to enable us to determine whether the model has learned or not. For our model design, we shall design an image classification model from scratch. This model will be trained to recognize the presence of maize streak and leaf blight diseases in images of maize plants. Then transfer learning will be used on two models, VGG19 and ResNet 50 as our baseline models. Shall transfer knowledge from those models. Then after that, we shall evaluate the models. We shall get the best performing models in terms of accuracy, precision, and recall. The model will be compared to other pre-trained models VGG19 and ResNet 50 to determine which model performs the best task of diagnosing the maize streak and leaf blight diseases. The best performing model will be selected based on its performance on the evaluation metrics. Then after there, we shall have to do the model explainability to account for the prediction made by the model. So explainability basically is to improve the transparency and interpretability of the models, and basically to find out the rationale behind the decision-making processes of the model so as to be trusted by human beings. Purpose of explainability is to, one of the reasons is to, like, once we get to know the rationale of the decision-making process, we are able to even actually increase its performance by maybe improving that factor which led to that prediction, and also increase trustworthiness, like in the industry. People know what factor or feature led to the prediction. People are able to trust that model, especially in different fields. This in like the medical field. Then after that, we shall explain our bono using different techniques such as the LRP, also known as the layer-wise relevance propagation, the LIME, local interpretable model agonistic, and then we also have the ARP. The ARP basically shows us the features that contributed to the building of the model. Then after that, we shall deploy our model on a mobile application, allowing users to easily access and use the diagnostic system on their mobile device. They will be able to use their phones to diagnose uninfected maize leaf disease. Then after a user maybe scanning uninfected maize leaf, then he will be able that after capturing that data will be saved to our database. Then we are going to create a platform, a web application, which will act as an interface for the database so as to be able to maneuver the database and see the data. Then here are our expected results and discussions. Our model will be high. Its accuracy will be high, to have a high F1 score. Then to have its low loss, high precision, and a high recall. These are some of the expected results. This sharp basically shows how each feature of the data contributed to the building of the model, as you can see here. Then conclusion, we expect the developed intelligence system to be able to accurately diagnose maize streak and leaf blight diseases in images of maize. Then we shall use of explainable AI techniques to allow clear understanding of the model's decision-making process, provide valuable insights for farmers and agriculture professions. It is also anticipated that the deployment of the explained model on a mobile application will increase accessibility and usability for users, allowing for real-time guidance on disease management and optimization of maize cultivation. Performance of the model may be affected by variations in quality and resolution of the images used for training and testing. Then additionally, the effectiveness of the model may be limited by the availability and diversity of the data set and may not generalize well to other crop diseases or species. Future works, like future prospects. One of our future prospects, the first one is extend the scope of the study to include other types of diseases that affect maize plants, such as rust, fusarium wilt. This will allow the model to be more widely applicable and useful for farmers. Explore the use of, second one is explore the use of other image classification models or architectures such as CNNs, the convolutional neural networks, to see if they outperform the model developed in this study. Consider incorporating additional data sources such as weather data or crop management practices to see if they have an effect, an impact on the model's performance. Then for our research, these are references we used. The Rangi Hugh, the identification of corn leaf disease based on transfer learning and data augmentation. Zygang, identification of maize leaf disease using improved deep convolution neural networks. Then, as we conclude, we want to acknowledge Dr. Joyce Nabende for her insightful advice and allowing us to also use the AI lab where we got our data sets. Then we also like to express our gratitude to the AI research lab team for allowing us access the use of their maize data sets. Then lastly, also thank our project supervisor, Mr. Galiwango Marvin, for investing both his time and effort to see that our study is organized and also like improve our research. Thank you for listening.